I think CFD and structural simulations are now practically the bread and butter of every design house out there. You can't do simulation, you can't do design without these, without some sort of a high-end simulations product. Where do you see it still needs improvement? Where do you see the physics-based tools? We'll come to the database view, but what do you see where do you see the physics-based tools as they stand today, and where are they headed?
There are several areas of opportunity, I would say, and just thinking a little bit freely on the fly, I would say that let's assume, Mahesh, I'm just stating the obvious, maybe this is more for the broader community, that these software tools, these numerical analysis tools, all based on solving a certain set of governing equations numerically, right? And we might solve them from PDEs, or sometimes we might use mesh-free methods like Lagrangian methods, right? Where like discrete elements or Monte Carlo methods or something like that. But largely the foundation is some mathematical model.
Yes.
So if we restrict ourselves to the world in which those mathematical models are reasonably good and they're well understood, then I can start to say that there are some definite needs that I'm confident will get knocked down with time. In the CFD world, I believe we don't do enough to provide information to the user of the software about the goodness of results. Mm-hmm. So in other words, given a certain set of parameters and inputs to the system, we get results. Rarely do we know how good these results are without multiple computations.
Yes.
Let's say grid convergence studies, yes, or validation against benchmark data, right? I think that's a target-rich opportunity for us, where a combination of researchers and software implementers such as ourselves need to build in more capabilities into our software to provide guidance to the user about the goodness of solutions. Mm-hmm. Now, these might come from multiple methods, like there are better and better error indicators that are coming out in the research community based on prior computations. And some of them actually use machine learning as a methodology to learn the goodness of the solution. And the idea would be that ultimately, this is my vision, but I don't think it's a unique vision. I think almost every engineer I've spoken to, practicing engineer, would like that. Like when you're plotting out your experimental data, Mahesh, right? Yeah. You cannot imagine publishing your data with some error bars, right? Some qualification or quantification of what your error is, right? Yeah. So my vision is exactly the same for computation. Right? One way to do it is using mathematical methods like adjoint methods to give you sensitivities to inputs, right? Yes. You're well aware. Yeah. But we need to harness that better. Yes. And the second set of approaches might utilize machine learning to provide confidence intervals onto the calculation. So personally, I think that's a really big need for us in the market.